This recording will show you how to do linear regression in RapidMiner. So right over here, I'm gonna use the insurance dataset to run the linear regression. And in our insurance dataset, because it's a regression, so we need to pick a numerical variable as an output. And for this dataset, I'm gonna pick the charges as the output. And for the input, I'm gonna pick three, the BMI, age, and the smoker as the input variables. For linear regression, RapidMiner provides the operator called linear regression, and we can simply search linear regression, and that is the full name of the operator. And we can link it with our data set. And then we do see an arrow, and because we do not have all numerical variables and there are polynomial attributes. So that is one problem that we need to solve. Before you run a linear regression, you need to check the attributes you have in your data set and make sure that there is no nominal type data variables, and all the variables should be numeric. So since we do not want to use all the variables and we just want to use, let me put it here. So we just don't want to use 4 variables as input output. We can use a select attribute operator and to select a subset of attributes. So here in the select attributes, we can select a subset and only include the variables that we are interested in. The charges, say output, our BMI, age, and the smoker as input, and apply. And now those are our data set. And again, the smoker, it includes the value yes or no, which are labels, and that is a polynomial tab. It's not a numeric tab. So we will need to convert it into dummy variables using one-hot encoding. So that is the normal way we usually do work on the linear regression using categorical variables, and we usually use one-hot encoding to convert it into dummy variables. So we can use one-hot encoding and link it with our the output from a select attribute. So the thing we want to convert is we can do subset, and the one we want to convert is a smoker. So let's put the smoker here, and I'm gonna disable this one first. So let's see how the data looks like after we apply one-hot encoding. All right. So after that, we'll have all the 3 numerical variables right over here, and we'll have a smoker variable. And in case that smoker equals to no, and that is a result from one-hot encoding, and it looks okay. And now let's try our linear regression. So after we link that, we see there is another problem. It says that the input example set must have special attribute label. So that problem means that in our data set, and we need to define what is our input and output variables. So what is our dependent and independent variable for linear regression. RapidMiner itself, it doesn't know which one is a dependent variable. And you need to set a specific role. It's a special role called label. So that is what it shows here. So a special role called label, and which can help RapidMiner identify the specific variable as dependent variable. And for the rest of them, RapidMiner gonna use them as input variables. So we're gonna need to do one more thing and to set the or change the role for an attribute to label. The thing we can do is that we can use set role. So that is one operator that we can use in RapidMiner to pick our dependent variables. For set role, we just need to pick the attribute and the change charges and change the tab. And by default, all the variables you have in the data set, we have the regular tab, and we would like to one with a label. So we're gonna set our dependent variable into label row. And that is it. If you take a look on the data set directly, you will not see any difference. And on the data set itself, there's no difference. And all the values still here, and all the variables still here. And the only difference is that they highlighted your label, and it put it as a first column. Charges, now I highlighted as green. All right, so it looks good. And then now let's put our regression back. It seems okay, we don't have any error, and we can try to run the regression. So after you run the regression, and it's gonna give you a table, and which includes all the information that we care on our coefficients, including the coefficient value, attribute name, coefficient value, standard error, standard coefficient, tolerance, so that's things we don't need. And t-value, so that's the thing used for statistics test, and the p-value which shows the significance. You don't need to care about the code and the use of full stars. It's something special in RapidMiner. You can just check the p-value and manually assign the stars and to indicate significance level. All right, so that is one can do. And another tab, so that is the result. That's the first tab, the data tab, which will show you the full output. And the second tab, description, and show you the actual model and in a formula style that you're able to see how the model looks like. And that is something you can also report in your the written report as the final output. Okay, so that is the first thing we care, and on the table and coefficients. Now another thing that we want to do is to get our R-square. This is a linear regression operator. It doesn't provide you R-square. So in order to R-square, we're gonna need to do some special things. Remember that R-square is calculated using the predicted value or fitted value from the model and our actual output. So we will need to get a predicted value or fitted value based on this linear regression model, and then to calculate R-square. So let's firstly take a look on how we can get our fitted value. RapidMiner provides you one general operator called apply model, right over here. So apply model is the operator that can help you to apply a model on a data set or a example set. So it asks for two inputs. One is the actual model, so which is output from your model operator. A second one is the input data set. You can also get it from the model operator, and the second output is the example set. So now we can link these two with the two inputs and the apply model. Apply model can help us to apply the estimated model on the data set and give us the final or fitted value. So it gives two output. One is the actual model output, which is the same as the one we just saw using linear regression operator. Another one is a label, which shows the predicted value. So let's see the output first. So you run that and you will see two output. This one is the same as the previous one, and another one looks like a sample set and with two columns highlighted. One is our charges column, another one is called prediction charges, which is a fitted value using the estimated formula. So that is our fitted value, which can be further, we can use it to calculate our R-square. But again, this applied model, it doesn't give us R-square, and we will need to use another operator in RapidMiner, which called performance. And performance operator can help us to check, used to help us to evaluate the performance of the model. R-square is used as one measure to measure the goodness of fit, and which is a statistical performance evaluation measure. So that is why we need to make use of the performance operator to get R-square. And if you just search performance, that here are a lot of performance operator for different kind of models, for classification, for spot vector count, and for attribute count. And we'll need to use the one called the performance regression. And that includes all the statistical evaluation measures for regression model. So that is the one we use called performance regression. Performance regression asks for one input, which is the label data. So that is the one we get from the applied model, including the original data set and the predicted value. Let me put it up here, okay? And then performance give us the output, which is the actual performance. And the performance is a measure that you can choose under the parameters. If we would like to get R-square, we can make use of the thing called square correlation. We can check the first one. And you can use this square correlation. And that is the one which indicates the value of the R-square. So now let's see how it looks like. If I run it, that's our model, and we will see one tab called performance vector, and it's gonna give us called square correlation 0.747, and that is the R-squared value for our model. And you can report it, this one in your final report. So to summarize, basically here is the part that we can do to run a linear regression in RapidMiner. Before you run the model, you need to make sure your data set has the proper data type for all the variables, and you selected the variables that you want to use. And you convert your categorical variable into dummies, and also you need to set the rows to label on your dependent variable. Then after you prepare your data, you can further process the data to linear regression operator. And in order to get the R-square, we need to use two additional operator, apply model and performance. You can also check the coefficient result from the model output using this linear regression operator. So using this process, you should be able to get the linear regression coefficients and significant level and R-square.